let me just go ahead and introduce this theorem first, and then we'll show you how we're going to use it. Okay? Let's say we want to, let's say we've got the polynomial x cubed plus 2x squared minus 11x plus 12. And the question will be, what are the possible, and that's the key term here, possible rational roots of this polynomial? Remember that there are other kinds of roots, right? We have irrational roots. That's like roots that have square roots in them and stuff like that, right? We have imaginary roots. That's roots that have like I. This list that we're going to come up with only has rational roots. That is like integers, positive, negative numbers, right? And then also fractions as well. Okay? So, here's how we come up with the possible rational roots. First thing we're going to do is identify P and Q from our polynomial, okay? P is the lead coefficient. Q is the constant term. In our example up here, what is P? Okay, what's the lead coefficient though? What's the coefficient of x cubed? 1. 1. And so in this case, from the example, P is 1. And what is Q from our example? 12, right? It's the constant term, it's the number at the end there, 12. So Q is 12. Okay. Then every possible rational zero has the form, so every possible rational zero has the form, oh goodness, I flipped this around. I'm sorry, guys. My mistake. P is the constant term, Q is the lead coefficient, and that's going to be important, so let me fix that. I apologize. Sorry about that. Okay, so it's Q that is 1 and P that is 12 here. Sorry about that. Okay. So again, that's P, and then that's Q right here, the 1. Which, as you can see, I don't know what, yeah, anyway. P is the end, Q is the start. P is the end, Q is the start. So I'm sorry about that. Okay, but then this next piece will be in the right order. It's factors of P over factors of Q. Okay, so in other words, what are some factors of our number P here? In other words, what are some factors of 12? Andrew, what are some factors of 12? 6 and 2. What else? 3 and 4. 3 and 4. What else? 1 and 12. Okay? And not only positive 1 and positive 2 and positive 3 and positive 6 and positive 4 and positive 12, but also negative 1. So really it should be plus or minus, all of these. Okay? What are the factors of Q? In other words, what are the factors of 1? That's easy. Plus or minus 1. Okay? So again, if we were going to try and factor this thing, you can look and see. The GCF isn't going to work. Factor my grouping will not work. I can tell you that right now. There's no other tool to use except for dividing. Synthetic division or long division. Okay? Without this tool, we are left to guess any number we can think of. We're left to guess any possible number we can think of. An infinite number of numbers. Okay? With this tool, with the rational roots theorem, we now have a list we can now list all the possible rational zeros or rational roots. Okay? And it's just the combination. So it's going to be plus or minus. So we have plus or minus 1 over plus or minus 1, which is just plus or minus 1. We have 2 over 1, 6 over 1, 3 over 1, 4 over 1, 2 over 1. So it's going to all just be those numbers again. Oops. Sorry. Thank you. Okay. Excuse me. So, yes, there are 2, 4, 6, 8, 10, 12. There are 12 guesses that we could make here. Okay? If we're really bad guessers. There are 12 guesses that we could make. That we would have to make to see if they work. Okay? But those are all the possible rational zeros. How could we check to see if one of these numbers worked? What would we do? You could plug it into the polynomial. And what would you look for? You would want it to equal what when you plug it in? 0. If it's going to be a root, if it's going to be a 0, that number when you plug it in better give you 0. So that's one option. You could plug it in and see if it gives you 0. What's another option we could check? What's another way we could check to see if one of these things work besides plugging it in to get 0? What else should be true? You plug in 0, no, that would give us the y-intercept, but that wouldn't give us a 0. What else could we use? We just used it earlier in this class period. What else? What else can we use here? You could also use synthetic division. Synthetic division would also work. You could use, so for example, rather than, if Greg wants to, he could take, for example, if he wants to check 1, he could plug 1 in, see if he gets 0. If he gets 0, great, we know that that's a root. Alternatively, we could use synthetic division, put 1 in the box, and then do synthetic division. The benefit of doing it that way is that when we do, and if it works, so for example, if we plug in 1, if we use 1 and synthetically divide here, what kind of polynomial will be our answer? This is a cubic, right? If 1 works, our answer will be a what? A square or quadratic. Okay? At that point, we don't have to guess anymore. We can just check to see if that quadratic factors. You see what I'm saying? Right now, if we use the first strategy, if we use the original strategy Greg mentioned by just plugging in positive 1 here and see if it gets 0, that's one way to check to see if it works, but then you still have to go and check every other single number until you get 3, right? Potentially. Sometimes you only get 1.
And what would you do to act plus that number?
So the factor, if you're checking positive 1, you check positive 1 in the box, because that's the root from the 0. X minus 1 would then be the factor. Right? If 1 is the 0 or the root, x minus 1 would be the factor that divides out. The opposite idea, like we were talking about.
Put it in equation, found through roots, how would you put it?
You could list just like x equals 1, x equals this, you know, if the zeros are, you can just list them as x equals those things. Or you could say the factor is x minus 1. Okay.
And the opposite of that number.
Would be then the factor. Yeah. So it all really depends also on what you're being asked too. So let's try another one here. Okay, let's try another one. So again, let's do another example. And again, let's list all of the possible rational roots of all right, let's try this and that one. 4x to the fourth minus x cubed minus 3x squared.
You need to slide it down.
Yeah, I'm sorry, plus 9x minus 10. Okay, sorry about that. Okay, 4x to the fourth minus x cubed minus 3x squared plus 9x minus 10. Okay, so we have to identify our P's and Q's, right? Jordan, what's our P here? What number is our P?
10.
The negative 10, or just 10 is fine. Yep, so there's P. Okay, Jordan, what's the Q? Yep. Okay, Q is 4. P is negative 10. So, now you need to list the factors of P, and then divide that by the factors of Q. All right, so I'll go to someone else for that there. Jordan, thank you, sir. Let's see here. Stephanie, factors of P, what are they? What divides 10 evenly? Okay, so plus or minus 1, right? Plus or minus 2. Go ahead, yeah. 5, you said?
10 is 5, plus or minus 10.
Yeah, and that's all of them, right? How about 4? Yep, and 4. Okay. Yep, good job. So now if we're going to list all the possible zeros, right? Again, this is the format they're going to have. So then all the possible zeros would be all possible rational zeros. Sorry, I keep saying that. All possible rational zeros. Okay. So now this is a little bit different, right? We have 3 numbers that are factors of Q. Before we just had 1. It was just 1. So that was easy. It was just 1 over 1, 2 over 1, 6 over 1, 3 over 1, 4 over 1, 12 over 1. But now, what do I have to do? Well, 1 over 1, 2 over 1, 5 over 1, 10 over 1, which is just 1, 2, 5, 10. And then I got to do 1 over 2. So plus or minus 1/2. Ugh, fractions. 2 over 2, but what does that simplify to be? Which I already have listed, so I don't need to list that one again. What about 5 over 2? Do I have that listed? Nope. 10 over 2? Do I have that listed already? 5, right, so I have to do that one. Oh crap, and I gotta do 4. 1 over 4. 2 over 4. Do I have to list 2 over 4? 2 over 4 is the same thing as 1/2. I already have it. 5 over 4, I don't have that. 10 over 4, do I have to list that one? 10 over 4? No, that's 5 over 2. Okay. So you can see that this is helpful, but it's still not great, right? Because we have a lot of possible guesses we would have to make here, right? So right? Sorry, yeah, like this. So 2, 4, 6, 8, 10, 12, 14, 16. So if we're bad guessers, we're going to be making like 16 guesses here. Okay? Or if there's no root. Because again, these are possible rational roots. They may not work. None of them may work. Okay? None of them may work. And again, how can we check to see if they actually are rational zeros? When you take from this list and you start guessing and checking. You plug them in, like Greg said, see if you get 0, and that means it would be a 0. Or you could use synthetic division to guess and check too. Okay. I'm gonna have you guys try one here. So you guys try this one, okay? And then we'll actually like do some guessing and checking. So try, again, list all possible rational roots of 2x cubed plus 3x squared minus 11x minus 6. Okay, so you all go ahead and try to do that. Just again, list all possible rational zeros, like we did here for the very last step. Okay, I'll come around and help you as necessary. That's what I want you to try. Okay, so I'll give you like a minute or two to work on that, and then we'll show you. So let's Connor can give this one a try just to see if you can do it. Okay, and I'll show you guys how we're going to use that list. Of possible rational zeros. Can identify the P, identify the number that's P, identify the number that's Q, and then list the factors of P over the factors of Q.
How would you plug in 1 here? have x equal a certain number.
So the way you can do that, for example, let's say you want to make x equal to 5. You can press 5, and then the STO for store, and you can store it into the variable x. So anytime you use x, it'll be 5. Now, if you go to like your y equals, it'll still be the variable x. It won't use the value of 5. But on your home screen now, if I do like 5x, 5 times 5, 25. Okay?
Great.
Ooh, alternatively, I'll show you something else here too. You're trying to guess and check using a calculator, right? So an alternative way to do that is to type the polynomial in your calculator. So let's do that here real quick. Okay, like that. Then you can go to your table.
Yeah.
You can check in here, right? So like you can see what numbers you want to plug in from the table there, right? So let's say you want to plug in 2. Oh, 2 is a 0. Okay. Or even more interesting, if you press second window for the table setup, if you go here and change the independent variable, well, you know how to do that to ask, and then you can then plug in whatever numbers you want. So, okay. So let's take a look at this here. All right. Let's go to Connor. So Connor, what in this polynomial here would be our p? Which number is p? Connor. 6. Very good. You heard Carlos. Carlos, what's our Q number? 2. Okay, so that means all the possible zeros must be of the form factors of P over factors of Q. In other words, Connor, what are some factors of 6?
Plus or minus 3.
Uh-huh.
Plus or minus 1.
Uh-huh.
Plus or minus 2.
Uh-huh. And one more.
And plus or minus 6.
There it is. Very good. All right, Carlos, what are some factors of 2? Uh-huh. There you go. Very good. All right. And so we can finally make our list. Okay, so then I'm just going to start abbreviating here if you'll permit me. All possible rational zeros will then be 1, 2, 3, or 6 over 1. So it's just plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And then 1 half. 2 halves you already have is 1, and then 3 over 2, exactly right. And then 6 halves you already have 2, it's 3. Okay, so there's our list. Only 2, 4, 6, 8, 10, 12 numbers to guess, right? So easy. Okay. There it is. Well, let's actually find the rational zeros. Let's actually find them. Okay, so let's actually now find the rational zeros. Okay, so find the rational zeros of, and we're going to use that same polynomial, 2x cubed plus 3x squared minus 11x minus 6. Okay, we've got our possible list here. Now we're going to find the actual ones. These are only possible rational zeros. We're going to find the actual ones now. Okay. What's the most number of rational zeros we're going to have here? 3. How do you know? How do you know there's going to be at most 3 rational zeros here? What gives it away about the polynomial? It's a cubic. Degree of 3. You won't have more zeros than you do a degree. Okay? So, all right. Let's go to Patrick. So Patrick, guess a 0 for us. I hope you're a good guesser. It's a little Russian roulette right now, right? Except not as serious, because you won't die if you lose. 3?
Yeah.
Positive 3?
Positive.
I hope you're a good guesser. Is there? Oh, the pie game? No.
How the cake?
How's it work?
It's in Japan. It's basically you load fake little plastic cartridges into this gun that's actually a hippo, and then if you mess up, it kicks you in the head.
Is that the one you're talking about? Okay.
I was watching
On YouTube,
Yeah.
you followed a rabbit trail on YouTube one day, and you got to this video.
Yeah.
Right. No, well, I always like. You guys ever played Bean Boozled?
Yeah.
That to me is kind of like a Russian roulette, because you like spin the spinner and then you either get a good one or a bad one, you know, kind of
They
thing.
just
So.
added like 2 more napkins.
Yeah, they change the flavors up.
Spoiled eggs and rotten fish.
Ugh.
I like messing with my baby's sister.
Yeah, I can imagine. Here's the candy. It's like, oh, thank, blah, you know. All right, anyway, let's try 3. Hopefully Patrick's a good guesser. If not, that's okay, though, because he had a lot of choices, and we really don't have any idea which one's going to work or not. All right, so I'm going to use synthetic division here. Again, why? Yes, Greg's method of plugging in is faster to see if it's a 0 or not, right? If we plug in the 3, and if it gives a 0, it's a 0. But this is helpful because if Patrick gets correctly, we'll get it down to a quadratic, and then we can just factor it. We can stop guessing, right? Because that's really what's going to take the most time is guessing. So, okay, let's see here. Bring down the 2, 6, 3 and 6 is 9, 9 and 3 is 27. That's going to give us 16. 16 and 3 is... Bum, 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 bum. Okay, so it didn't work. All right, we got a remainder of 42. Okay, good news. We now only have 2, 4, 6, 8, 10, 11 more things to guess. All right, Patrick, guess again, please. 2? All right. I hope you're right. Positive 2, right? All right. So 2, 3, negative 11, negative 6. All right. Drop down the 2. 2 times 2 is 4. 3 and 4 is 7. 7 times 2 is 14. Negative 11 and 14 is positive 3. 3 times 2 is 6. Ooh. Very good guess, Patrick. All right. We get 2x squared plus 7x plus 3. So 2 is a 0. And now that we have this quadratic, we can stop guessing and try and do what? Factor it. All right, let's use the magic x here. All right. So, Patrick, what number is going to go up here in the top of the x? 6. That's what you meant to say. Right. And what's the middle? What's going to go in here? 7. So we need 2 numbers that multiply to 6, but add to 7. 1 and 6. Yeah, there it is. And now we'll divide both of those by that 2 that we multiplied back. 6 divided by 2 simplifies to 3. 1 divided by 2, well, it doesn't simplify. So this thing factors to x plus 3 times 2x plus 1. And so we can set that equal to 0 to find those other zeros. So x equals negative 3, Patrick. You were really close with the 3. It was actually just negative 3. And then x equals negative 1/2 was the other one. Thank goodness we didn't have to guess negative 1/2. That probably would have been like one of the last ones we guessed, right? So there they are. So x equals 2 is a 0 as well. Okay, so there are our 3 rational zeros. In this case, all 3 zeros were rational here. So that's what you'll be doing when it comes to problems like this, okay? You're going to come up with a list of possible rational zeros, and then to actually find them, you're going to have to guess and check with synthetic division. My recommendation, start at like 1, then try negative 1, and then the next highest one, so maybe like 2 and negative 2, something like that. Try and avoid the fractions if you can. I'll write the problems in such a way that you won't have to worry about like all fraction answers, okay? You'll get some answers, and then you should be able to go from there. Okay, questions on any of that? All right, then here is your assignment. Okay, so on page 374 in the book, so you're going to want to take a picture from these green books. Okay, you're going to want to take a picture from the green books. I'm going to have you do numbers 3 and 5, and that's just listing the possible rational zeros. Okay? Okay? Just listing the possible zeros. That's the P and the Q, that's it. And then for one like we just did with Patrick, I want you to try 11 and 17. Okay? And this is find all real zeros. Okay? If you can't get the quadratic to factor, you can also try using the quadratic formula too. Don't forget.